Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back another video related to the ANN Artificial Neural Network in MATLAB Simulink. So in this video, we will understand how ANN will use to turn on and turn off this fixed capacitor according to the load requirement. So as you are all aware about it, we have already uploaded a lots of video related to the active power factor improvement case. So as you can see, I recently uploaded one fuzzy logic controller, and fuzzy logic controller used to improve our power factor by turning on and turning off this capacitor bank. So we are now one step forward, one step ahead, and we will use ANN artificial neural network technique that is inside the MATLAB Simulink or deep learning method that will use to turning on and off this capacitor bank. So what you need to do first, you need to first remove this fuzzy logic controller block. Then you have to be some data. You have to be prepare some data. So I have already prepared one data. You can see this is the data, and yes, this A line is our power factor and B line is our numbers of capacitor bank that have to be on and that as per the power factor. So for the sake of simplicity and as accuracy, I have considered the four digit after the decimal. So that's why we have, I think, 10,000 data, and we will place this data in MATLAB Simulink and check how ANN is work. So I just copied this data. So this is our first power factor. I just copy it and pasted in MATLAB Simulink. So how you can start? First of all, the artificial neural network technique, you need to first design the variables. So for designing the variable, I just press the new variables and then paste all the data. This is a power factor and its name is unnamed, and I can transport it. So you can see all the data is in the row. And is it possible to change the name? I just check input. Okay, I cannot change, so it is unnamed. Okay, no worry. Then I have to add another new variable which will be our output. So you can see what is our output. This is the output. So I just need to copy all the data and paste it over here and just transport variable. Okay, so right now we have input and right now we have output, because any type of ANN artificial neural network require inputs, and according to that, according to calculation, it will generate the output. So right now what you have to do, you have to write the NF tool. Once you write the NF tool, you can see this types of interface will be open. Then you need to go to the next, and then you need to select the input and output. So what is your input? Input is unnamed. You can see unnamed is our input and unnamed one is our output. So I am just considered unnamed one as a output. Then I have to go to the next. Then you must not change the data. Mostly we are going with this type of iteration: 70% training, 15% validation, and 15% testing. If you are not getting accurate result, you need to change this value, but right now we are not changing, we are just considering this fixed value or standard value. So this is the numbers of hidden neurons inside this calculation. How many neurons is there? How many layers is there? So yes, standard number is 10. If you are not getting accurate result, you need to increase or decrease as per your requirement. So right now we are not changing anything because we have only one input and one output. So I am just considering this 10 and go to the next. Then I have to consider the which type of algorithm should I have considered. So one is the Levenberg-Marquardt method, is another is Bayesian regularization method, and third one is scale conjugated gradient method. And most cases we are going with this one first, Levenberg method. So I am considering it, and then I will press the train. Once I will press the train, I will get the result, and result must be near to 1 or as near as possible to 1. So as you can see here, the training is completed and we are getting 9.9792. All the values are 0.009 and near to 0.99, so which is near to 1. And if you want a regression, you can plot the regression also. Take some time to plot, but yes, you can see all the values are near to 1 and all the values are 0.997, 0.99. So all the values are near to 1. And if you want more accurate, you need to change the layers, or you need to change the percentage ratio that we have already seen. Okay, so I think this result is okay, and and then we can go to the next, and we can, if you want, you can retrain the model, but we don't want to retrain. We are okay with this data and we are going next, and then we want a Simulink diagram. So as I press the Simulink diagram, I got one MATLAB function block. So as per the input, it will generate the output. So you can see here, if my input is 0.0014, then output must be 1 or near to 1. I just change the constant and check what will be the output that I am getting. So I am change the input value to 0.0014, and then I will check the output. For the output, I need to use a display module to get the exact value, and then I have to run the model, and we'll check whether am I getting the exact result or not. So as you can see that I have run the model and I am getting value which is near to, exactly near to 1, and 1.01 it is near to 1. So right now you have the MATLAB function block and you can use in any type of simulation as per your requirement. So I just copy it and just paste it over this our fuzzy logic block, and I have already deleted that fuzzy block, and right now I will use ANN block, artificial neural network block, and how, and we will check how it is working and whether it is as per our requirement or not. Okay, so I need to connect it with this properly. So as you can see here, we have replaced our fuzzy logic block with the ANN block, and we'll check how accurately the ANN is working. And obviously ANN is more powerful than the fuzzy logic controller, and check whether it is working satisfactorily, because as you are aware about it, if you go through the fuzzy logic video, there is slight variation and it take more time to stabilize. So that same thing is happening here also or not, that we have to check. So as you can see here, I just started the simulation and we'll check. So as you can see here, simulation is started and we are getting 1 as the output, and that's why only one capacitor bank is on. Remaining is off. And what is the power factor? Power factor is 0.9851, which is very satisfactory. Now we are increase the load, and what happen and in how much time it will stabilize, we have to be checked. As I start the simulation, there is slight variation, and in very few amount of time it get our value, and which is near to 2. And right now two capacitor banks are on, two capacitor banks are off, and we are getting power factor 0.9817, and which is working very fast. I just increase the load once again and check how it's, you can see again 3, very fast, very accurate, and we are getting the power factor. Again I increase the load, very fast, very accurate. So you can see there is no any such variation and it is working very fast. I just wanted to check the power factor, so you can check the power factor over here. So I just, okay, there is slight variation, and if you change the style and change the scale, then I can say you will get slight lower variation, because right now it's zoomed too much. So if you reduce the minimum value like say 0, then you can see there is very less variation in the system compared to the fuzzy logic controller, and it is a very fast, I can say, and in very small amount of time it can change the variation in the power factor and generate down. Okay, and similarly we can reduce it. So yes, as I reduce, the capacitor must be reduced and accurately work. Okay, so if I reduce both the load, I can say I have reduced both the load. So you can see it come to the 2. It means that only 2 bank is on, and yes, the power factor is also maintained. If I reduce once again, the 2 will reduce to 1. If I increase one load once again, it must be increased to 2. Okay, if I increase the load once again, it must be increased to 3. Okay, so you can see it is how accurately ANN is a perfect tool to design such logic. And for this type of on-off controlling and just for the simple in input and output, ANN is working very satisfactorily. But you need to have this type of data, and data must be as more as possible and as accurate as possible. So this is how you can design the ANN for your system and for your electrical network, and it is a very powerful tool specifically in the MATLAB simulation. So thank you watching this video, and if you have still any query, just comment it, I will definitely reply. And if you want this simulation file, that is available in the description box. And for any type of MATLAB or electrical or electronics project or simulation based project, you can connect with me through my email ID or through my WhatsApp chat, that is also given in the description box. Thank you very much.